Something just happened to 3I Atlas that has NASA deeply concerned. For weeks, this interstellar visitor was behaving exactly as predicted, moving quietly through the inner solar system. Nothing unusual, nothing unexpected, just another space rock following the laws of physics. Then, without warning, it exploded. Not literally, but close enough that astronomers are scrambling to understand what they're seeing. Because what's happening right now shouldn't be possible at this distance from the Sun. If you want to see why scientists are calling this the most baffling comet behavior in modern astronomy, hit that like button and let's dive into the data. Because this story is about to get very, very strange. Weeks ago, astronomers were tracking 3I Atlas with routine confidence. Standard observations, predictable patterns, everything moving according to the textbooks. But then something changed, something fundamental. A surge appeared in the ultraviolet data. Not a small blip, not a minor fluctuation, a massive, unmistakable spike in hydroxyl emissions, the chemical fingerprint of water being violently torn apart by sunlight. At first, research teams thought it had to be a calibration error, someone's equipment malfunctioning, a software glitch, because what they were seeing simply couldn't be real. Distant comets at nearly 3 astronomical units from the Sun, that's roughly 3 times the distance from Earth to the Sun, simply do not release this much water. The physics doesn't allow it. The temperature is too cold, the sunlight is too weak. It's like watching ice cubes melt in a freezer. It shouldn't happen, yet the signal kept rising. Wave after wave, hour after hour, day after day. Until observers across multiple continents, using completely different telescopes with completely different instruments, finally realized they were all witnessing the same extraordinary event. This wasn't an error. This was real. Reports from observatories in Chile, Hawaii, Australia, and Spain described the water outflow in terms that scientists rarely use. Violent, sustained, completely out of scale for a body this far from the Sun. One senior researcher at NASA compared it to a broken fire hydrant in space. That phrase spread through scientific channels like wildfire, because nobody, and I mean nobody, had a better explanation for what they were seeing. NASA hasn't issued a formal public interpretation yet. But internally, the event triggered an immediate operational shift. From routine monitoring to active alert status. From casual observation to intense scrutiny. Because a sudden, massive increase in water loss suggests something has changed structurally inside the object. And structural changes in interstellar visitors are notoriously, dangerously unpredictable. What makes this moment even more unsettling is how it unfolded. There was no gradual build-up, no slow ramp-up, no transitional phase that typically precedes major comet outbursts. The kind of warning signs astronomers rely on to predict these events simply didn't appear. Instead, 3I Atlas seemed to snap into a completely new state, almost instantly, like flipping a light switch. One moment, quiet and dormant, the next moment, violently active, as if something beneath its ancient surface suddenly released all its pressure at once. Scientists are now staring at the raw data with a mixture of fascination and concern, unable to determine whether this is a temporary outburst that will fade in days, or the beginning of a much larger, much more dramatic evolution. Right now, there's only one confirmed fact, and it's the one that worries researchers the most. 3I Atlas is losing water far faster than the physics at this distance should possibly allow, and until NASA understands exactly why, they cannot predict what comes next. They can't model the trajectory. They can't forecast the behavior. They're flying blind, and that terrifies them. What makes this entire event so deeply unsettling isn't just the sheer amount of water that 3I Atlas is losing. It's where it's happening, the location in space that makes absolutely no sense. Let me explain why this breaks the rules. At nearly 3 astronomical units from the Sun, sunlight arrives at less than 1/10 the intensity that we experience here on Earth. At that distance, solar radiation is far too weak to drive intense water sublimation. The heat just isn't there. Ordinary comets at that distance barely release a trickle of vapor, a whisper. Their surfaces remain frozen solid, their water ices locked beneath thick, insulating layers of dust and rock that prevent the weak sunlight from penetrating deep enough to cause melting. Yet 3I Atlas is ejecting water at an estimated rate of roughly 40 kilograms every single second. Think about that for a moment. 40 kilograms. Every second. Continuously. That's 88 pounds of water blasting into space with every tick of the clock. Over 3 tons per minute. More than 4,000 tons per day. And this value has been confirmed independently by multiple observatories using completely different measurement techniques. This isn't speculation. This is hard data. That number shouldn't just be low at this distance. According to everything we know about comet physics, it should be almost zero. The detection of hydroxyl is the critical clue here. When water molecules break apart under ultraviolet light from the Sun, they fragment into hydrogen and hydroxyl. That hydroxyl leaves a spectral fingerprint, a unique signature in the ultraviolet spectrum that astronomers can measure with incredible precision. The massive spike in hydroxyl emissions around 3I Atlas means the object isn't releasing a thin mist. It isn't gently outgassing. It is violently venting significant quantities of water in a continuous, powerful stream. And this is happening while the object still receives less than 1/10 of the solar energy it will encounter later when it swings closer to the Sun during its closest approach. Physically, chemically, thermally, the numbers simply don't line up. They contradict each other. This level of water loss suggests internal conditions that do not match the slow, gradual warming expected at 3 astronomical units. For such a powerful outflow to occur this far from the Sun, something must be forcing buried water reserves outward with tremendous pressure. A sudden fracture deep inside the nucleus, a newly exposed reservoir, an internal collapse, something violent. But here's the problem. If this were typical, normal cometary behavior, we would see similar outbursts in other distant objects all the time. Comets at this distance would routinely blast water into space. But we don't. We never do. Solar system comets only produce fire hydrant-scale water jets when they're much, much closer to the Sun, when their surfaces are heated intensely enough to vaporize deep ice layers, when the thermal energy is sufficient to overcome the insulating crust. The contradiction is crystal clear and impossible to ignore. The sunlight is too weak, the surface temperature is too low, and the distance is too great for natural sublimation to explain what we're witnessing. Even the most experienced comet researchers, scientists who've spent decades studying these objects, openly admit that this level of activity makes absolutely no sense within our current thermal models. Every unanswered question points back to the same deeply unsettling possibility: that the surface of 3I Atlas is not behaving like the surface we think it has. That something about this object is fundamentally different from everything we've studied before. And that difference might reveal something extraordinary about where it came from and what it really is. To truly understand why this eruption is so completely baffling to scientists, you need to understand what 3I Atlas actually is, where it came from, how old it is, what it's been through. This isn't a young comet from our own solar system. This isn't some chunk of ice that broke off from the Kuiper Belt a few thousand years ago. 3I Atlas is an interstellar traveler, the third one ever confirmed in human history. A body that has wandered between the stars for an incomprehensible length of time. Current estimates suggest it's been drifting through the galaxy for 7 to 14 billion years. Let that sink in. 14 billion years. That's nearly as old as the universe itself. That journey alone makes it radically, fundamentally different from anything that formed in our solar system. While local comets spend most of their lives protected in the cold, dark outer regions of our system, tucked away in the Oort cloud or the Kuiper Belt, 3I Atlas spent unimaginable stretches of time in open interstellar space, completely exposed, unprotected, subject to the full, relentless force of galactic cosmic rays. And those cosmic rays reshape an object at the molecular level, atom by atom. Over billions of years, they carve away lighter materials, reorganize ice structures, and build something extraordinary. A dark, incredibly hardened shell around the entire nucleus, a protective crust of processed, radiation-damaged material. Current estimates suggest this cosmic ray crust on 3I Atlas may reach 15 to 20 meters deep. That's 50 to 65 feet of hardened material, thicker than most cometary surface layers that form through ordinary solar heating by an order of magnitude. Think about that protective shell. 20 meters of radiation-hardened crust acting like armor. That means the pristine, icy interior of 3I Atlas, the water and volatiles that formed billions of years ago, should be buried beneath a layer so incredibly tough, so resistant to heat, that weak sunlight at 3 astronomical units would barely scratch it, would barely warm the surface at all. Under normal circumstances, under every model we have, the water locked deep inside would remain completely sealed away until the object was much, much closer to the sun, until the thermal energy was strong enough to penetrate that thick, protective barrier. But that's not what's happening, not even close. The size of 3I Atlas only adds to the puzzle. This object is far larger than Oumuamua, the first confirmed interstellar visitor that passed through our system back in 2017. And it's dramatically more massive than 2I Borisov, the second interstellar object discovered in 2019. Interstellar objects of this scale are already incredibly rare. We might only see one every few decades. But interstellar objects this large that still retain deep, accessible water reservoirs after billions of years of cosmic ray bombardment, those should be virtually non-existent. Because cosmic rays don't just build a protective crust, they also gradually deplete the volatiles. Over billions of years, radiation should have driven away much of the accessible ice, leaving behind primarily dry, carbon-rich materials. Dead, inert rock. Yet here it is, not dry, not quiet, not stable, not dead, but suddenly, violently, impossibly blasting out water like a high-pressure industrial vent. This is why researchers are genuinely unsettled. Everything about the structure, composition, and evolutionary history of 3I Atlas suggests it should be highly resistant to water loss at this distance. The cosmic ray crust should be acting like a sealed vault. Instead, we're seeing the complete opposite. A water outburst strong enough to rival comets that are 2 or 3 times closer to the sun. Comets receiving 10 times more solar energy. That means something fundamental has changed deep inside the nucleus. Something broke. Something opened. Something that was sealed for billions of years has suddenly been exposed. And if that ancient cosmic ray crust truly fractured open, if the armor finally failed, then what lies beneath may be far less depleted, far more volatile, and far more pristine than anyone expected. We might be looking at water ice that hasn't seen sunlight since before our solar system even existed. If 3I Atlas is losing water at a rate only seen in comets much closer to the Sun, then something beneath its ancient surface must have changed. Suddenly, violently, catastrophically. And the leading explanation among researchers is both elegantly simple and absolutely terrifying. The cosmic ray crust cracked open. After 7 to 14 billion years of continuous bombardment by galactic cosmic rays, the outer shell of 3I Atlas had become something extraordinary. A hardened layer between 15 and 20 meters thick. Not ice, not rock, but something in between. Processed, compacted, radiation-damaged material that acts like armor plating. That shell serves a critical function. It seals the interior. It prevents heat from reaching the deeper, pristine ice layers. It keeps everything locked inside, frozen in time. But armor, no matter how strong, can fail. And when it does, when that protective barrier finally gives way, the pressure that's been building beneath it for eons has only one direction to escape. Outward. Explosively. A sudden fracture in a crust that old would behave exactly like a ruptured pressure valve on an industrial tank. Imagine a sealed container that's been pressurized for billions of years suddenly developing a crack. The moment sunlight begins penetrating through that crack and heating the freshly exposed interior ice, water vapor builds rapidly inside the nucleus. Gas expands. Pressure increases exponentially. And with nowhere else to go, with no other weak points to release through, the vapor forces itself violently through that single opening, creating a jet powerful enough to mimic the exact broken fire hydrant behavior that astronomers just reported. Laboratory studies of radiation-processed ices support this scenario. Scientists have taken ice samples, bombarded them with high-energy particles to simulate cosmic ray damage, built up protective crusts, and then studied what happens when those crusts fail. The results are dramatic. Once the crust cracks, outgassing can jump from near zero to explosive levels almost instantaneously. No gradual buildup, no warning period. Just a sudden, violent switch into overdrive. That would perfectly explain the abrupt surge in hydroxyl signatures that shocked researchers. No buildup, no warning. Just an instant transition from dormant to hyperactive. This scenario also helps explain why the outflow appears to be dominated by water rather than carbon dioxide or other volatiles. Carbon dioxide ice sublimes at much lower temperatures than water ice. If the crack penetrated deep enough into the nucleus, if it reached all the way down to the core, it could be exposing layers that have been completely untouched since the object first formed. Those inner regions, shielded from cosmic ray erosion for billions of years, could still hold pristine water ice. Pure H2O, in the exact same form it existed in when the object condensed from the primordial molecular cloud that gave it birth. The result would be a column of water vapor, unlike anything produced by the heavily processed outer layers. A direct glimpse into material that is literally older than our sun, older than Earth, older than anything in our solar system. But while the crust fracture hypothesis explains the violence and the water dominance, it raises its own deeply unsettling questions. Why did the crack form now? Why at this specific moment in time? Why at this particular distance from the sun? And most importantly, why did it form in a way powerful enough to overcome an insulating shell that should, in theory, be nearly impossible to breach without intense, sustained heating? Even more puzzling is this. The water jet appears sustained rather than momentary. It's not a brief burst that fades after minutes or hours. It's continuous, ongoing, relentless. That suggests the crack isn't just a surface fissure. It's a stable conduit, a channel reaching deep inside the nucleus, possibly all the way to the core. If that's true, the reservoir feeding this jet may be absolutely massive. And if it continues at this rate, we might be watching the slow disintegration of an object that has survived intact for billions of years. But there's something else, something even harder to explain, something that doesn't fit the natural model at all. Here's where the entire situation transforms from puzzling to genuinely disturbing. If 3I Atlas is venting water at the rate astronomers are detecting, roughly 40 kilograms every single second, then that jet should be producing a clear, easily measurable push on the object itself. This is basic rocket physics. Action and reaction, Newton's third law. When a comet releases material in one direction, when gas and dust blast out from its surface, it creates thrust. The object accelerates slightly in the opposite direction. It's exactly how rocket engines work, except instead of burning fuel, you're vaporizing ice. With a water jet this powerful, this sustained, this massive, the resulting force should be straightforward to model, simple to predict, and obvious to detect in the trajectory. You plug the numbers into the equations. You calculate the mass loss rate. You determine the exhaust velocity. You compute the thrust vector. And you predict exactly how the object's path through space should change. Basic orbital mechanics, textbook physics. But that's not what researchers are seeing. Not at all. The acceleration profile of 3I Atlas does not fully match the thrust expected from a water-dominated jet. The numbers don't add up. The trajectory isn't following the predicted path. Even when scientists account for the carbon dioxide streams that were detected earlier in its journey, even when they include those additional thrust vectors in their models, there are still unexplained deviations. Some of the motion fits, some of it matches beautifully, but not all of it. And the part that doesn't match, the part that refuses to fit the equations, is exactly what concerns mission planning teams and orbital dynamicists. The jet is real. The water loss is confirmed. The thrust is definitely there. But it isn't producing the directional push that the physics absolutely says it should. There are possible explanations, of course. Natural explanations that could potentially account for the discrepancy. Maybe the internal crack is angled oddly, sending thrust sideways instead of directly away from the surface. Maybe the surface is rotating in an unusual way that smears the jet's effect over time, averaging it out. Maybe the crust is acting like a nozzle, widening or narrowing the opening as the nucleus warms and cools, changing the thrust dynamically. Scientists have simulated all of these scenarios. They've run the models. They've adjusted the parameters. They've tried every reasonable variation. But even when they account for all these factors, something still feels wrong. The numbers don't line up cleanly. And the mismatch becomes more pronounced, more obvious, more statistically significant the longer the outflow continues. The contradiction deepens when you consider that this water jet isn't a brief flare. It's not a temporary burst that lasts for hours and then fades. The data shows it has remained strong and continuous for days. That kind of sustained outgassing should create a stable, consistent, completely predictable acceleration pattern. Instead, the outbound motion appears irregular in subtle but measurable ways, as if the forces acting on the object are shifting and changing faster than standard cometry processes should allow. Some scientists have begun drawing uncomfortable parallels. They're comparing this pattern to earlier anomalies noticed in 3I Atlas's behavior before it reached perihelion, before it made its closest approach to the Sun. Patterns that also resisted simple natural explanations. Patterns that made people start asking uncomfortable questions. This doesn't necessarily mean the event is unnatural. It doesn't prove anything extraordinary is happening. But it does mean that nature is behaving in a way we don't fully understand, in a way that challenges our models, in a way that suggests there's something deeper going on that we're missing. A powerful water jet should simplify the dynamics. It should make the trajectory easier to predict, not harder. Instead, it has complicated everything. It has added new layers of mystery to an object that was already defying expectations. And until 3I Atlas emerges from behind the sun, until we can observe it directly again, no one can determine whether the thrust is changing over time, strengthening, weakening, or being masked by something deeper happening inside the nucleus. Right now, the equations are perfectly clear. The venting is real, confirmed by multiple independent sources. The water loss is enormous, unprecedented for this distance, and the acceleration does not add up the way it absolutely should. That gap, that unresolved discrepancy between observation and theory, is exactly why NASA elevated its monitoring status to active alert. Something about 3I Atlas still refuses to fit the models, still refuses to behave like it should. And that unknown factor, that missing piece of the puzzle, could be the key to understanding what this object really is. All of the confusion, all the unanswered questions, all the contradictory data now funnel into a single critical moment in time. The reappearance of 3I Atlas after it clears the solar glare. Right now, at this very moment, as the object moves behind the sun from Earth's perspective, we are completely, utterly blind. We've lost visual contact. No optical telescope can track it through the sun's overwhelming brightness. No ultraviolet spectrograph can measure its chemical output while it's hidden in the glare. No spacecraft is positioned on the far side of the sun to watch the event unfold directly. The most violent, most critical phase of its activity is unfolding in complete darkness. We can't see it. We can't measure it. We can only wait. And only when the object emerges on the other side will we finally know what truly happened during this critical blackout window. The first thing scientists will examine with intense scrutiny is the coma, the cloud of gas and dust surrounding the nucleus. If the water jet was caused by a temporary crack, if it was a brief structural failure that has already sealed itself, then the jet should weaken dramatically. The hydroxyl signature should drop. The outgassing should decrease, and the object should return to a quieter, more stable state. That would be the best-case scenario. It would mean the outburst was a one-time event. Unusual, yes. Extraordinary, absolutely. But ultimately finite and predictable. But if the jet has strengthened during the blackout period, if new emission lines have appeared in the spectrum, if additional volatiles are now venting alongside the water, then that means something much more significant has happened. It would mean the fracture penetrated even deeper into the nucleus than anyone initially expected, that it opened a pathway to layers buried for billions of years, layers untouched since the object formed in some long-dead stellar system. In that case, the outgassing could grow even more intense. It could reshape the entire coma structure. It could reveal fresh, pristine material that has never been exposed to sunlight since before our solar system existed. We would be watching, in real time, as an ancient time capsule from interstellar space cracks open before our eyes. Next, astronomers will carefully analyze the color and brightness of the object. Any sudden shift toward bluer wavelengths in the reflected light would strongly hint that fine dust grains or tiny ice crystals were blasted out violently from deep within the nucleus. That would suggest a significant structural disruption, possibly even partial fragmentation. A stable color curve, on the other hand, maintaining the same spectral characteristics as before perihelion, would support the idea that the outburst was brief and localized. A surface event rather than a deep core event. Scientists will meticulously compare every measurable detail: the dust production rate, the size distribution of ejected particles, the light scattering properties, the polarization characteristics. They'll compare all of this against the pre-perihelion data, looking for any changes, any evolution, any signs of how the nucleus transformed during the blackout. But the most important test of all, the measurement that will either confirm or shatter our current understanding, will be the outbound trajectory. If the jet's thrust matches natural predictions, if the acceleration finally aligns with what the water loss rate says it should be, then the mystery might have a conventional solution. The motion should settle into a smooth, predictable path that can be explained by standard cometary outgassing physics. That would be reassuring. It would mean we understand what's happening. But if the jet continues at the same intensity, or even strengthens, and the acceleration still refuses to align with the physics, if the trajectory still shows those unexplained deviations, those subtle irregularities that don't fit the models, then we may be looking at the beginning of a new anomaly. One that cannot be explained by simple venting, one that cannot be dismissed as unusual crust fractures or volatile ice pockets, one that demands a different kind of explanation entirely. This is the critical juncture, the moment where the natural model either proves itself correct or breaks under the weight of contradictory evidence. For an object older than our sun, for a traveler that has spent billions of years drifting between the stars, this moment carries absolutely enormous implications. 3I Atlas has already defied our expectations at every turn. It challenged our thermal models. It behaved unlike any distant comet should. It showed characteristics that don't fit comfortably into our categories. Now, in the coming days and weeks, the universe will provide its next update, its next piece of the puzzle. Whether the outburst fades quietly away, intensifies into something even more dramatic, or evolves into a completely new form of activity that we've never witnessed before, the data gathered after perihelion will define the next chapter in this ongoing mystery. One thing is absolutely certain, regardless of what we discover. We are witnessing something no scientist currently alive has ever seen before. An interstellar object, billions of years old, undergoing a violent transformation in real time. Right here, in our solar system, under our direct observation. And the story of 3I Atlas? It's far from over. In fact, it might just be beginning. So what do you think is really happening inside this ancient traveler? Is it a natural process we simply don't understand yet? Or is there something more going on, something we haven't even considered? Let me know your thoughts in the comments below. And if you want to follow this story as it develops, as new data comes in, as we finally see what happened during the blackout, make sure you subscribe and turn on notifications. Because when 3I Atlas reappears, when we get our first clear look at what it's become, that moment could change everything we thought we knew about interstellar objects. The universe is full of mysteries, and right now, one of the biggest is heading directly through our cosmic neighborhood. Stay curious, stay watching, and get ready for whatever comes next.